And I love list comprehensions as well. The only thing I'm going to tell you is that a list comprehension explicitly generates a list. So let's look at what a list comprehension looks like. So the funny thing is that a list comprehension, we're going to start out with n equals 8. What am I trying to do with n equals 8? I'm trying to square the first n integers. So I want to generate the squares on the values from 1 through 8 inclusive. So a list comprehension looks like a list, right? So you can say something like open square bracket and close square bracket. And then the next thing in there is what you're actually trying to generate. So what we want to generate, the output, each element in our output list is going to be the square of our value. Square of our value. And now what we want to do is we want to write something that looks like a for loop. So what we want is these are the input values that we want to generate, right? So we want to generate x, and we can use our range function, right? What values of x do we want to generate? Well, we want to generate 1 to n plus 1, right? Because we want to generate 1, 2, 3, 4, 5, 6, 7, and 8. We don't want to generate, 1 through 7 or 0 through 7. And that's it. That generates a list, right? This is kind of like a recipe. This is a recipe for what to do with your values, and this is the values to choose to apply to the recipe. And it just applies these one at a time to the values we generate, right? Values we generate, and comes out with a list of values. And that's called a list comprehension. And it turns out that we have this map function that allows us to do, right? We could do this just as easily with a map function, right? In fact, we did this in a map function, right? It would just be a list map lambda x squared comma range 1 n plus 1, right? Same exact values. So what is this, right? This is the bounds of the for loop, right? Or the list that we're iterating over, right? We could do this with W or whatever other list we wanted, right? This value goes here, right? This goes here, and then this goes here. And it's just a simple little translation to get between a list and a map. So they work somewhat equivalently. The advantage a map has is that the map doesn't necessarily have to generate the entire list, whereas the list comprehension will. Okay? And now if map has an analog in this list comprehension, right, in this for part of the list comprehension, then I'm gonna assume that, well, I don't have to assume, I did these notes once, that the filter does as well. And in fact it does. So let's start off with a different kind of list. This list is not just 1 through 8. This is 1, 9, minus 4, minus 8, minus 3. And what did I want to do with that? Oh, I just want to filter those out. So I just want to filter out, remember we filtered out all the negative values before. So let's write a list comprehension that filters out those negative values. Well, this time we're just going to want the list value itself, right? Because if we pass something through, if we pass, for example, 1 through, we want this to be 1. So the result of our operation is going to be the list value. We'll do the same thing we did before. We'll write the for x in V, right? Where x is here and here, right? This is the generated value. This is what we do with it. We're going to pass it on unscathed. And now we can actually add an if clause. We can say if x greater than 0. Right? So what this will do is it'll take x, it'll throw it through every single element of V. 1, 9, minus 4, minus 8, 10, minus 3. And if x is greater than 3, it'll appear over here in the output. Right? So we would expect to get back 1, 9, and 10, right? And we did this, right? We did this as a filter, right? Someplace. Oh, dang it. We're getting close. There we go. Let's just take that sum off, and then we'll be good. Oops, we got to throw a list in here. There we go. Right, so this is exactly the same thing. And again, what we did was we took this if x greater than 0, right? The if essentially says this is a filter operation. This is the result of the lambda function. And right, we just take this here and pop it up here. And of course, you know, as you may have kind of surmised by now, if we can put map and filter together, undoubtedly we can put this if and a comprehension together. So let's say we want to square all the positive values. So we want this to be 1, 81, and 100. Well, we start off by doing our list comprehension. The return value is going to change. Everything else pretty much stays the same. For x and v, if x greater than 0, and that should generate our squares. Yeah, it can be, these are very, as long as these match, things are cool, right? This tells you what you're going to call it. This tells you the condition it has to face, and this tells you what the output generation is going to be. Now, I kind of whizzed through this one. It helps to have somebody in there answering questions for me as we kind of go along. Both map, right? A map function can be an input to another map function, right? Because a map generates something that looks like a list. So we can always do right? So we can always do a map lambda x return, I don't know, x sub 1 comma x sub 0. And let's do that for we'll do that for another map that is lambda x and this time let's just return x0 plus 1 comma x right. So hopefully that'll work, and we'll apply this to our points. So what we're going to do is the first time through we're going to execute this map, and it's going to generate a list-like object that increases each one of these values by 1. So this will be 3, 6, 13, 4, 13, 2, 7, 6, etc. And then this one's just going to swap the order. So this becomes the input to this one. Just like a filter can be the input to a map can be the input to a map. Let's see if I got it right. No! Invalid syntax. Oh. I have been telling myself LAMBDA every time I typed it except for once. There we go. And of course we need our little list thing. All right, I had a really good stretch going here. Make one mistake, it opens up the doors, right? So now what we've done is we've swapped the order on them as well. And if we look at points still, right, instead of 5-2, we now have 6-3. And instead of 12-3, we have 4-13. Okay, so a map can be an input to a map. A filter can be an input to a map. And just like that, we can actually do multiple 4s in here. So let's look at generating all the pairs of numbers between 1 and 4, except for the pairs where the numbers are equal. So what we want to do is we want to generate 1, 2, 1, 3, 1, 4, 2, 1, 2, 3, 2, 4. Okay, so we want to generate all sets of pairs except where they're not equal, except where they're equal. So we're going to need 2 variables for this. We'll have x and y, right? We want to return a tuple, so we'll return a tuple, and we'll say for x in, and now we'll do range, what, 1, 5? Yeah. 1, 5, right? That'll generate the numbers 1, 2, 3, and 4. So we've told it how to generate the x. Let's tell it how to generate the y. For y in range 1, 5. Right, so now we're generating the x's. We're generating the y's. We haven't told it which ones to use, but we can say if x not equal to y. Right, so now we're generating 1 through 4 for the x's. We generate 1 through 4s for the y's. This is essentially a nested for loop, so for every new value of x, we'll generate all the values of y. And on those occasions when x doesn't equal y, we'll put out x and y to this result stage. And, right, this is what we expect. 1, 2, 1, 3, 1, 4, 2, 1, 2, 3, 2, 4, 3, 1, 3, 2, 3, 4, 4, 1, 4, 2, 4, 3. And if we wanted, for example, we showed you how to get rid of the diagonals before. If we wanted to get rid of not only the diagonals, but all pairs of matches, right, 4, 3, if we decide that 4, 3 and 3, 4 are the same and we only want to keep 3, 4, we can do x less than y. And that should generate 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, 3, and 4. Right, so that gets rid of all duplicate values if the order of the tuple is arbitrary. All right. Thursday will be a review of the final. Your exam is on the 17th, not on the 16th. It's going to raise some havoc with grading because that shortens our grading time by 2 days over what I wanted and 1 day over what I thought we had. But we will soldier on. Map and filter. Take a sequence, an iterable, produce an iterator as a result. We talked through this. List comprehensions are kind of fun. The only issue with that you can get rid of lambdas if you use list. You can often get rid of lambdas if you use list comprehensions, but then you're committing yourself to generating the entire list explicitly as opposed to generating it on the fly. These are examples of functional programming. They're kind of a fun thing. Lisp used to be the big example of functional programming. You did a lot of recursion. You did a lot of these defs in there. We've also looked at imperative programming. That was kind of the beginning of the course. And when we finally got into classes, that's object-oriented programming. Python is inherently an object-oriented system, but we can use it in multiple different ways. And we've kind of demonstrated that. That's all I have. I am 2 minutes past my time, which is kind of a record for this class. I'll stick around for the next at least 15, 20 minutes. I know there was at least one of you who wanted to talk to me. If you could hold on for a few minutes till we've answered any general questions, we'll break off into a private room if you need to, or